Okay, let's do one more example of combining our transformations, including domain and range. So, first thing we're going to do is state the transformations based on vertex form. From there, transformations, we have a reflection in the x-axis with a vertical stretch by a factor of 3 or of 3. We then see that it is shifted left or right. Brackets lie, so instead of going towards the positive side on the x-axis, we're going to the negative, which is left. So we are shifted left 4 units, and then up 1. Units, spaces, whatever we want to say. Okay, mapping notation with 5 additional key points. Remember, mapping notation is that our 5 key points are those 5 points that we start from a quadratic, our most basic quadratic. Remember that is y equals x squared. That's how I've got all that. So what's going to happen? Only the shift left or right affects the x values. So shift to the left means we're going negative and 4 units. Our y, the reflection, to make it open down, and our stretch affects the y, so it's negative 3 times y, and then we're going to add 1. So that's our mapping notation. Here's our 5 points, and we're going to say how they transform according to that math. So for the first point, our x value is negative 2. When x is negative 2, take away 4, it moves to negative 6. Negative 1, take away 4, moves to negative 5, 0. So those are going to be my x values. Corresponding y values takes a bit more work, either in my head, on a scrap piece of paper, on a calculator. The 4 times negative 3 is negative 12, plus 1, negative 11. 1 times negative 3 is negative 3, plus 1, negative 2. 0. Now this pattern, because this middle one is my vertex, that's why I chose those 5, should follow. So I can fill it in, or if I'm not sure, I do the math again. 4 times negative 3 is negative 12, plus 1 is negative 11. Follows that pattern. Now this is the vertex in 2 points to the left and 2 points to the right for my quadratic and vertex form. So I'm going to draw my vertex first, negative 4 plus 1, negative 3, negative 2, and negative 5, negative 2, negative 6, down to negative 11, 2. There's my parabola. I can take my time, draw it. Arrows on the end to show that it's opening down forever. My vertex. Here's my vertex. I have a vertex, negative 4, 1. Again, my axis of symmetry is the x-coordinate. My max or min is the y. It opens down, so it has a maximum, a max of 1. Again, I can take that from my graph by saying negative opens down, so that's my maximum. My axis of symmetry is my x value for my vertex, negative 4. Negative 4, positive 1, there's my vertex right away. And here's mapping notation. So I filled out all that. Now, linking it back to domain and range, all the possible x values that it could be, it opens down forever, which means it's always going to go left and hit all the numbers and always going to go right. So my domain is every real number possible. My range is going to have a cap at the top, max of 1. So y is every set of real numbers such that y needs to be less than or equal to 1, because it opens down forever. So eventually all the negative numbers, or every number less than 1, will get hit. Now, the way I can manipulate this, if I only wanted to care about the part of the graph that, say, goes to here, I can now change the range or the corresponding domain. So if I, let's say, wanted to only look at from there to there, I might say I'm only going to, and when I write this down, I'm only going to include the numbers such that -6 is less than or equal to x is less than or equal to -2. And now I only have my graph go that far, and it actually has endpoints as opposed to going on forever. Now this little extra bit is something that we can add to control what part we look at or zoom in on, or where the graph ends. So if I included this as part of my original question, I would actually only draw it to there. And I would not have arrows on the end because it doesn't go on forever. And then that would affect what my actual range is. The highest is 1, the lowest is -11, and I would include that. That is if I want to control it. If I'm just stating this particular thing, there it all is. So this will come in handy later on when we try our evaluation and our understanding of domain and range as it applies to quadratics.